Hey, what's up everybody? Welcome back to another layer by layer tutorial. In today's tutorial, we're going to jump into some more CAM in Fusion 360. This week's project, I put together an LED acrylic sign and I had to do a little bit of engraving. So I used the CAM tools in Fusion 360 to make this cool CircuitPython sign. So let's jump right into Fusion 360. So the first thing you'll need to do engraving on a CNC machine is to have some artwork. So what I have here is some artwork that I put together in Fusion 360, but it doesn't have to be. It could be something from an SVG file, like a vector file, or a DXF file. All of those will work just fine as long as your paths are fully closed. So the engraving operations in Fusion 360 will only work with fully closed shapes, and you'll know it's fully closed because it has this kind of orange color to it, and you can select it like that. So if you're trying to do just single lines, let's say something like this, let's say you want to do this shape here, you will not be able to select it because it has to be an edge. So for example, if you do want to do something like this, I found a way to do it. You actually just have to kind of make it look like these. So these are these little fake traces that I made. And the way I made these is just by kind of making an offset and then closing the two lines so that I can create a full selectable closed profile. So if you are trying to make just a line, you will have to kind of close it in itself like that to make a fully closed thing. So we're going to be working on just this one for starters. So again, these are all fully closed paths, and they are selectable. I made them in Fusion 360 using our good old spline tool and some good old lines. But again, this could be an imported SVG or an imported DXF. So one thing I want to note is you actually don't need to have a model, a solid model, in order to do this. In order to do engraving, you really don't need a model. All you really need is paths. So let me show you how to set this up. So let's say we have this, and let's say our stock is already kind of shaped. It's already in the shape that we want. Let's say we wanted to mill this on the back of an iPhone or an existing piece of acrylic that already has like a nice shape or something. You wouldn't really want to model it per se. You don't have to model it. You could just start off with the path. So let's go ahead and jump into the CAM. So I'm going to open up our model workspace here and navigate to the CAM tools. Now we're in the CAM. The first thing I'm going to do is create a new setup. A setup is basically an arrangement of different machining operations. So I'm going to build one now. So I can click that. And the first thing is it wants to know what your box point is. This is basically saying what is your origin on your CNC machine. So by default, it is in the center. And for me, I'm using the Othermill Pro. And this is the Othermill Pro software. It's called the Otherplan. And you can kind of see what it looks like there. It's kind of 3D and cool looking. So the Othermill, their origin can be either on the left or the right. But typically by default, it is on the lower left corner. So that is where our origin is. And that's kind of what we need to do in Fusion. So back into Fusion, I'm going to select this guy over here. There's a bunch of these little white dots. I'm going to select this one here. So my Y is going up that way, X this way, and our Z is going up that way. So that's basically all we need to do for the first part here, the stock box point. Okay, I don't have a model selected. There's nothing here, so we don't need to worry about that. The next tab is where we're going to define our stock itself. So if you have a piece of stock that has a very specific value, this is where you want to change the mode. Right now, the mode is in relative size, so it'll relatively size itself automatically if you have a model. Since we don't have a model, I'm going to select and change this to fixed size box. So here it gives me an X, Y, and a Z, so I can change these to reflect my actual piece of stock that I have, which happens to be 100 millimeters by 101 millimeters by 6 millimeters. So that's how thick it is. And you don't have to put millimeters if you don't want. You can put inches in there if you want. Now you notice that here that we have these extra drop downs. This is center. This is the model position. So right now it's centered, and that's okay. But if you are trying to be kind of conservative about your material, you really want to use as less material as possible. So what I'm going to do is I'm going to actually change these guys to offset from the left side on the X, and on the Y I'm going to make it offset from the negative Y, and on the Z I'm going to make this offset from the bottom. So I'm going to put some numbers here. I'm going to kind of change this around. So the offset here, I think I'm going to do something like 3 millimeters, and for this one on the Y I actually want it to be something like 3 millimeters, or maybe even negative 3 millimeters. See, what I'm trying to do is basically get this artwork as close to this corner as possible, not fully, but a little bit, so that we have all this extra area here that we can work with. And this is, you know, you can always change this later, but I just thought it'd be kind of useful to note that you want to be a little bit conservative about your material. You don't want to just mill it in the center and then have all this excess area that might be thrown away. So it's kind of nice to kind of think about using every piece of the buffalo, as you've probably heard that before. If not, hey, that's one thing. Use every piece of the buffalo. So be conservative about your material, right? Okay, so now that I kind of have it set up here, I'm going to hit, well, let's take a look here at this side here. And you want to make sure that your stock is below your paths, because we're milling from the top, right? So we want to make sure that our stock is set 0 here. So if you look at the offset here, it says it's coming from the bottom, negative 12. Actually, right here, sorry, the model position is set to 0 here, coming from negative 0 or negative Z. So I have that set to 0, and that's where we want it. That's ideally where we want this. So that looks pretty good. We have our origin set up, and we have positioned our path kind of further away, to close to the origin, so that we can reuse all this material. Okay, and that's really much everything we need to do there. So I'm gonna hit OK. Now that we have our our stock set up, we can kind of work on getting our engraving. So an engraving is a part of the 2D categories here. So under the 2D dropdown, you'll find the engrave operation under this guy here, under circular, in between circular, and in between 2D chamfer. So I'm going to click on that. We get our engraving panel here. The first thing I'm going to do is select our tool. So real quick, the Othermill has a library of tools. It's a specific Fusion 360 library, and there's all the tools that the Othermill, kind of the common tools that are used for Othermill. Obviously, you can have a whole bunch of different ones. Fusion 360 has a bunch of them by default. These are for different manufacturers and stuff, but I did have to import this. This is in an external library. I won't cover how to install this. There is a great tutorial on Othermill's website on how to install that. I'll link that down in the description, but you can go to othermachine.co/support, and then it's somewhere in here. I'll have a link for you guys, but we don't really need to cover it now. So I have all these tools. These are tools from Othermill, of course, and since we're doing engraving, the best tool to do that is, well, the engraving tool. This is an 80-degree engraving tool. All the kind of feeds and speed settings are already kind of set up for you, but they will change depending on the material that you'll be milling. So let's say if you're milling acrylic, it'll be different than milling, you know, aluminum. So I'm going to hit OK on that. And we're not going to worry about the speeds and feeds yet. We just want to worry about kind of setting up our geometry and setting up our heights. So all this is okay. I recommend following these feeds and speeds that are listed. These are suggested settings that are listed for each individual tool here. You probably don't see the engraving tool here, so just kind of use maybe this one here, since it's one of the smallest tools. But we're not going to be covering that. We're mostly going to be covering up just setting it up, okay? So let's not worry about the speeds and feeds. Those are important, but again, we're not covering it. I'm going to go into geometry. The geometry tab is really where you want to select your path. So one of the things that is a little bit limiting here is you can't select all of this. I wish you could mark you select this. If y'all know a way to do that, let me know, because currently I know you have to kind of select all of them by hand. So if you have a bunch of them like I have here, you kind of have to select them one by one. And again, you can only select kind of profiles that are fully closed, not lines that are just regular lines. They have to be fully closed. So one thing to know, if you accidentally select something you didn't want to select, you can remove it by clicking on it again, and then you get this menu here. You gotta hit the trash can icon to actually remove it. A little bit weird UI, but that's the way it works. I'm just gonna select it again. Okay, and of course you could hit the X here if you want all of them. So I'm just gonna select this one here and just stick with that. This is just to kind of speed things up a little bit. So the next thing I do, the most important thing really, after you've selected your contours or your profiles, you're gonna wanna go to the heights. So this is where we're telling the machine where the top is, where the clearance is, when to retract, and all these things here. But really what you need to focus on is the top height. So currently it is default selected contours. I'm going to change that and make it stock top. So I'm basically saying that the top height of this operation should be starting from the stock top. The next thing I'm going to do is you'll see this bottom height. It's setting going from the top height. And that's okay. That's what I want. I'm actually going to zero this out because by default it wants to go that far down. And I'm going to hit this 0. And what I'm going to do is I'm going to say that I actually want to start engraving at a negative value. How deep do you want to cut from your stock top? Well, I want to cut 0.2 millimeters deep. So that's what I'm doing here. So it's a little bit confusing for me to figure out at first, but that is what seems to work out the best for this specific project. So again, it's stock top for the top height, and I'm doing an offset of a negative 0.2. I wouldn't go any deeper than that. Of course you could, but then because the way the tool is, it has an 80-degree chamfer on there. So the further you cut, the kind of deeper and wider your paths are going to be. So that's the way I have it set up. Again, I changed this from select contours to stock top, and I put an offset to negative 0.2. I left this, the bottom height, as the top height, and then I zeroed this out. So watch what happens when I hit OK. That's basically all we need to do. All these other tabs don't really matter for the engraving operation. I'm just going to hit OK. What you'll get is a render, or these blue lines. These are extra blue lines, the path of our path. So it looks kind of weird, so I'm going to actually hide the component, and that way you can get a better look. Now we didn't select all the contours, so I know that. We just wanted to speed up time here. So that's what it looks like. It looks pretty good. If you want to see it, we have to click the simulate button. So I'm going to click on that, and that's going to give us a nice simulation. I'm going to turn on the stock. That gives us an idea of what it looks like from the stock's perspective. And then I can play this and get a simulation of what the operation is going to look like. So let's zoom in here, and you can see that it is cutting our path. It is doing an engraving, so that means it is just doing the outline. It's not actually filling in the thing like I had in the model. It is just it is just guiding that tool along that path. So let's play it again. You can see it playing there. So it looks pretty good. This is just a render. It doesn't actually look like this on acrylic. And on acrylic, it looks much cleaner. It doesn't look all chipped up and kind of weird looking. You can change the material. It doesn't really look, any of these options, that looks terrible. I think the best one for me personally is the mirror. That looks okay. And you can do other things, like you can turn on this tool path to get a visualization of it. But I tend to turn it off just so I can get a good visualization of the actual simulation. So it looks pretty good. And of course you can kind of move this, drag this black thing around, the little playhead, I guess you can call it. You can play that around. You can play around with the speeds if you want. This isn't really actual speed of the machine or anything like that. You could probably set that, but I'm not sure how to do that. But hey, the point is to kind of get this going. So we didn't model anything yet. We're just using the paths that we put together in that sketch. So you can definitely engrave something. Like again, if I was engraving on top of a box, on top of a phone, or some existing object that's already, kind of complete, this is what you would do. You would want to set it up in this manner so you don't actually worry about the model or a solid body. You're just worrying about setting up the profiles correctly. So that's pretty good. The next thing I want to kind of cover is actually having a model. So let's turn on the model. I'm going to get rid of this one, get rid of this graving, go back into the model, and we'll turn off our sketch and turn this guy on. So this is what I have. Let's say we want to model it like, or we want to use this guy as our reference, you know, for our milling operation. Go back into cam. Whatever reason, it just kind of shut it off, so I'm going to bring it back. And I will set up the engraving, or actually I want to actually redefine our setup here. So I'm going to double click on that, and you'll see that it's not, you know, it's not correct. So in this case, now that we do have a model, I'm going to select the nothing button here and select our model. And now it's selected. So what I can do now is I can go into the stock tab and change the fixed size to relative size. And now it automatically kind of sets my model as the stock, but you'll notice that there's a little bit of extra gap here, so that it likes to default add some offset to the top of the stock, so I'm going to put that to 0. And the sides are okay. I like that there is a little bit of padding around the edges of this model, and you just want to be aware, look at the dimensions. You see it's 86 by 57. Well, you want to make sure that that doesn't exceed your actual stock that you're using. I'm in the Otherplan software right here, and you can see that I have a piece of acrylic or a piece of material that is 101 by 6 millimeters. So you just want to make sure that you are within those bounds and that you're not kind of cutting air here. So you want to make sure that your dimensions in your relative size box, and it's just a kind of quick and easy way to get your stock set up. But it really doesn't matter what my stock is, as long as it is, you know, smaller than my actual stock. So that looks good, and again, you want to reference your dimensions to make sure that's accordingly. But of course, you could also use the fixed size and rework that as you want. But it was just easier for me to hit that relative size, because it's just, as you saw, I just kind of readjusted everything for me, and it looks pretty good. So again, I want to make sure that I have 0 offset on the top and bottom, because I don't really need to face this material. I'm using acrylic, so I don't need to face the acrylic. All right, I'm going to hit OK. And now I am going to show you what happens when you try to select these edges here in the model. It's actually kind of weird. So watch this. I'm going to click on the engraving. Make sure my tool's selected. Pretty sure it's the right tool, but I'm just going to make sure again. So double click on the 80-degree engraving bit. That's set up. We're going to ignore the speeds and speed settings and go straight into geometry. So let's select our thing here. So what's weird is that because this is more of a extrusion and not paths, it's not really doing what I would expect. So this is a lot more counterintuitive. As you can see, it's like selecting these weird edges here. I can't really select the top edges. It's kind of bizarre. So it's not really, I don't recommend doing what I'm doing now. It doesn't really work that well. So I'm going to hit the X button, and I'm going to bring back the sketch. So that's where the sketch is. And you know what would be better is if I had a better visualization of what you're probably going to have. So let's say that I'm going to step back here and kind of make this this extrusion kind of go off of the grid. So as you saw here, I added a plus value there. So now I'm like extruding off of the grid instead of below the grid. And then I'm doing this just to kind of show you something here. So I'm going to hit from object to start the plane, and I'm going to start on that plane. So now basically we're kind of making this go off the plane here. And then I'm going to do the same thing for this cutout. So I'm going to start from object on the top here, and then hit OK. So basically all we did was we essentially made the model coming off of the X axis here instead of below it. So now when you look down on it, you can see that it is above that. So what does that mean for our cam operation? Well, the setup is still good. It's still fine, as it is using the model. So it's kind of parametric in that sense. So that's pretty good. But the thing is, now that we want to do the engraving, we still run into that problem where I can't really select these edges correctly. But watch what happens when I want to select our, our paths here. So we can still select it, but they're coming from the bottom, right? They're coming from the bottom. That's okay, because we can still tell our heights to start from the stock top or the model top. I recommend doing the stock top, because it just kind of works out that way. So that's working okay. And then we still want to do the same thing here, where we zero this out, and then we add the depth, our cutting depth, to the top height. So I'm going to put negative 0.2, and that will basically work the same way as we did in the beginning. So that works out. I'm going to go ahead and hide this and show the simulation here, and just you can click this button to go to the end of the toolpath to see that happening. So that seems to be working just fine with our model now selected. Okay, so now that we have the engraving, well, what about the cutout, right? So let's do the cutout. I'll bring back my my model here, and I'll hide that right there. If we want to do the cutout, I don't recommend doing an engraving. Obviously, we want to do a cutout. So the way to do the cutout is with the 2D contour. This operation works best for just kind of these 2D shapes here. It's 3D, but it's just cutting straight down. There's no overhangs. There's no kind of bevels or anything like that. So I'm going to click on that. You don't want to use the 80-degree chamfer tool, because that's for chamfers. You want a flat end mill. And I recommend using the 1/8 inch flat end mill, because it has the cutting diameter is the same shape, the same size as the shank diameter. So if you're using something like a 132, for example, flat end mill, you won't be able to kind of get that big cut, because this kind of chamfers here. So that's why I recommend using an 1/8 inch. But as we're going to see here in a second, you'll see that there are some caveats with it. All right, so now that I have that selected, again, I'm not going to worry about the feeds and speeds. I'll go right into geometry. I'm actually going to select not the top, but the bottom edge here. This whole thing kind of selects as a chain, which is what we want. So that's going to be the end of our, like, where it needs to go, where it needs to kind of cut all the way through this piece of acrylic. So I'm going to go into heights, and really I don't really need to select anything here, because this operation is kind of smart enough to know where I want it to be. So the top height is already set to stock top, which is what I want. That's where I want it to start. And the bottom height is selected contours, and that's basically where I want the thing to stop. Now, since we're cutting acrylic, I actually recommend going to your passes tab and enabling multiple depths. This will ensure that we are pretty conservative with our tool. Instead of cutting all the way through, you might break the bit that way. Depending on your CNC machine, maybe you can do that, but on the Othermill, I don't recommend doing that. So I want to make this a minimum step down of 0.2 millimeters. That's how deep of a cut I want to make, and Fusion will figure out how many times it needs to cut down until it gets to the bottom. So that's really all I need to do. So I can hit OK now, and Fusion will right away kind of show me a visualization of how many passes it needs to go down in order to cut this whole thing out. So let's go ahead and simulate that cutout with the operation selected. I'm going to hit the simulate button, and I'll turn on stock, and I'll even hide this just to kind of make it a little bit cleaner. And I'll just go right to the end of the toolpath, take a look at what it looks like. So what you'll notice is that actually some of the corners are sharp, but other ones are not sharp. So if I turn on my body back again, you'll see that it's supposed to be sharp there, but it can't, because, I mean, take a look at this thing running. It just can't get into nooks, you know, like this, because the tool itself is fairly large, and it's, well, it has a radius. It's a circular tool. So it can't get in between these nooks to make a perfect edge. That's just the way it is. If you were doing an inner cut, if you're doing like a cut from the inside, then yeah, it could do sharp edges, but we're doing it on the outside, so there is some limitations there. So just be aware of that. If you wanted to do this, you would just need a tool that has a finer tip with a long cutting diameter. Unfortunately, I can't use a 1/32 or a 1/16 inch bit, because the cutting diameter isn't it isn't long enough to actually cut through the entire piece of acrylic. So that's why I'm using a 1/8 inch bit. Okay, so as this is playing out, you can see how many times it has to pass through. And this is, again, this is just really conservative to kind of ensure that we're not putting so much force on the tool and breaking it. So it'll take a little bit, about 5 minutes. That ain't bad. It's still pretty quick compared to 3D printing. So this is what the end result will look like. So that's how to do a cutout. So that's really cool. So next up, what we want to do is we want to export these out. So let's say let's say that I selected everything here and this is exactly how I want it. How do you get these out into your post processing? Because unfortunately, Fusion can't really communicate with my tool. You still, my Othermill, you still need something to connect to your actual machine and run the G-code. So in this case, I have Otherplan, but for another machine, you'll be using something else. It kind of depends on what machine you have, but Fusion really doesn't do that. Fusion just exports the G-code. So before you export the G-code, I highly recommend you save your file. I don't need to save right now because I've already saved it, and I already have a setup saved that I actually used for the final production. This is just a test for the tutorial. But if you want, what I do recommend is that you save these out individually. Each each operation should be saved out individually. And to do that, you can right-click on it and hit Post Process. But you do want to save, because I have had several times where the Fusion will just crash. There's also a button up here under Actions. They have Post Process. So let me see. Cross my fingers. Hopefully it doesn't crash. Yay, it didn't crash. So what you want to do is you want to select your post processor. That might be a number of different CNC machines here. They have a bunch of different ones by default. Fortunately, they had the Othermill post processor here. It's right there. And that's really all you have to set. Just make sure that it's set up for your machine. If it's not there, then you'll probably have to download an external post processor script or whatever. But thankfully, Othermill is in there, so all I have to do is hit OK. And just kind of like as naming conventions, .gcode for this specific version of Otherplan, it doesn't recognize .gcodes as far as I'm concerned. This is version 1.17, so it actually uses different dot extensions. It uses a .nc, so that's the one you want to use. The way I like to name my stuff is usually by object name, so like call this sign, and then I'll name this whatever the operation is. So in this case, it's an engraving, and then I'll name the tool. So this would be 80 degree. And then if this was the contour, I would name this contour -1-8. That way I always know that it is what operation it's doing and what tool it's using. So that's just my convention. Y'all probably have a better way to do it, or you can name it whatever you want, but that's just the way I like to name it. So I'm going to hit cancel because I already saved these out. And really, if you want to get these into your Otherplan, this is how you would do it. So obviously you want to set up your material here. They have like some preset materials, but I always select the generic one, and then I add my size manually. So you can see that it's got the 6 for the thickness, 101 by 101. Take a look at the placement here, so you can actually tell it where you want it to be placed. I have it set to 0, 0 because I'm going to try to line it up as best as I can to the spoil board, the lower left corner. But you notice I have something here at 0.2. So what's that about? Well, if I zoom in really, really close, you can see that I am off the bed by 0.2 millimeters. And that's because I'm using double-sided tape. I'm using double-sided tape, and it's 0.2 millimeters thick. So whatever tape you're using, make sure you measure it. You measure the thickness, and then you input it here in your placement. So if I was using some thin tape and it was 0.1 millimeters thick, well, I would add that in there. And it's very important that you do add that in there. If you have it set to 0, then your tool will start milling into the tape. And that can be kind of okay, but you'll probably end up with a bunch of adhesive gunk on the tip of your tool, and that's not really good for the tool. So that's why I like to put 0.2 in there, just give it a little bit of extra stuff. And if it doesn't mill all the way through, you can always, acrylic is kind of forgiving, so that you can just kind of snap it off. It's like paper thin anyway, if it doesn't get all the way in there, which that tends to happen to me. But hey, that's just to kind of note there. The next thing I'm going to do is I'm going to bring in the files. So I'm going to click on the Open Files button and bring in these two guys here. I'm going to bring in the engraving first. And the first thing you need to do after it's been opened is you have to set your tool. So of course we're using an 80-degree engraving bit. So I have that set. Next thing I'll do is I'll bring in the contour. And I'm going to make sure I select the right one, which is the 1/8 inch flattened mill. And this is a great visualization. Really love the Otherplan software. I really haven't used any other CNC software. I don't have another CNC machine, but I would think that this is some pretty nice stuff. So as you can see here, it's cutting at the edge here. If you have, sometimes I've had this happen where it says tool collision. I'll get a little red warning that says there's a tool collision. The Otherplan software is smart enough to detect if like it hits the Z-stop or if it can't quite get into there. So what I recommend doing is dropping this little placement open, and you can basically add an offset here. So you can offset your artwork. Obviously I want to do that same thing for the contour. I'll make it off by a little bit. That way that if we're not exactly on the edge, on these two edges when we're trying to line them up, this just gives a little bit of extra gap here. We're still being pretty conservative because there is some extra space here. I can reuse this material for a smaller piece if I ever needed to. And I'm starting to kind of collect my own collection of like pieces, scraps of acrylic, which is kind of a good thing and probably a bad thing too, but hey, whatever. But hey, that's a good thing that you have this extra control of offsetting your G-code files. Just make sure that when you do so, that they are both doing the same, because if I have this, if this was set to 0, then it wouldn't be lined up properly with the engraving. So that's how that works. Don't have to worry about the Z, because we want to be following this, because whenever you update the placement of the thing here, your thing will move. Let me do that again. 1, and then you can see that it just the G-code moves with that. So let me show you again right there. You can see that the G-code's moving with that placement, because this is the overall material that's being moved. So that's kind of nice to know. We'll put it back to 0.1 or 2, whichever one it was. So there you go. That's how I set it up in Fusion 360 and in Otherplan. This again specifically for the Othermill desktop CNC machine. Now there are some other things I wanted to show you. One last thing is just a note about acrylic is that you actually notice that this artwork is flipped, and I'll show you why. In the video on the 3D Hangouts, which I'll link below, I actually show you guys the difference between milling, the difference between the two surfaces. Now acrylic is double-sided, and for whatever reason, the side that doesn't have the engraving makes a better effect. Like the artwork, engraving artwork, is much more punchier. It just looks much better on the side that doesn't have the engraving. So if I were to flip this around and you were to look at it, it actually doesn't look as bright or as diffused, which is very odd, and I didn't really understand that, and it took me a couple tries to really realize that, hey, this looks better reversed on it looks better on the side that doesn't have the engraving. So I came into this problem where I was like, okay, how do I flip my how do I flip the artwork? So obviously the first thing is to like, oh, just go in here and, you know, go into the move tool and change this to sketch objects and then flip it. Is that the way to do it? No, that's probably not the best way to do it. There's actually an easier way to do it. So the way I was able to do it, let's go back into Cam, and what I did was, let's go start off of this guy here, off of my setup. Sometimes double clicking doesn't work, so you can always right click and hit edit. What I had to do is, you see these arrows here? Well, you can click on these arrows to basically flip your work coordinates, your stock. You can flip it. So that's what I'm going to do. I'm going to hit that button. It flips it. And now it thinks that this is up and this is down. So that's already flipped because we're looking at it from the bottom. You can see there that we're looking at it from the bottom, and that flipped it just fine. Of course, the one thing you do have to update is you have to update the stock point. but that's fine. You could just click it over here and we're basically back to where it needs to be. We're oriented near the lower left corner because in Otherplan, that's just where the origin is. So you got to make sure to update your stock point. But other than that, that's kind of all you have to do. Now you'll get these errors here, but all you got to do is hit Command G or just right click and hit Generate Toolpath, and these guys will get refreshed. This got messed up because my body is hiding or something like that. So don't have to worry about that. But hey, that's how I was able to do it. All I had to do was just flip the Z stock and then update my stock point, and that seemed to work really well. So now when we generate this, when we simulate it and turn on the stock, you can see that it is doing exactly what we need to do. So we don't have to update any of the actual toolpaths in there. So once you have them all set up, it's fairly easy to just flip the stock and then have your artwork, you know, on the reverse side. And that looks pretty well. Now I'm not sure why this guy didn't work, the contour. Maybe, what happened here? Maybe it's just hiding or something. Let's see if I can fix it somehow. Double click on it. Oh yeah, we just have to update the geometry, of course. So we'll get rid of that chain, and then we'll select this one, and our multiple depths and everything else should be fine. So I'll hit OK. And there we go. So I guess you do have to update that one, but that's about all you have to update. And then if I simulate this guy, turn on the stock, turn off the body, and then just go all the way to the end of the toolpath, we can see that that's what it looks like. Obviously, I didn't select all the engraving paths, but just imagine I did. But that looks fine, right? So that's how I was able to quickly flip the artwork here, because I don't think you could flip it inside of Otherplan. I don't think you could do that. But hey, that was really, really easy, and it worked out way better this way. I really recommend, if you are engraving acrylic on your Othermill and you are going to edge light it with an LED light or whatever light, I definitely recommend you flip your artwork. You know, if your artwork is symmetrical, then you don't have to worry about that. But if you're doing typography like I am here, then you'll definitely have to do that. So that's pretty much all I wanted to cover. This was a bit of a long one, but I really wanted to thoroughly explain how I set up the engraving toolpaths and the contour in Fusion 360 and get them out into Otherplan. So it's kind of a good look at kind of using both software. They work really well with each other, and you get a lot of control in an Otherplan to kind of offset your G-code and stuff. So really, really cool stuff. I learned a lot. I hope you learned stuff too. If you guys have any comments, any suggestions, anything like that on what I covered today, please let me know in the comments. I love reading your guys' comments. And if you are interested in the project, I'll have it linked below. I also have a link here to the acrylic that I use. This is Lucite. This is light guiding specific, light diffusing acrylic. And also, if you want more feeds and speed settings, I know I didn't cover that, but if you do want some feeds and speed settings, the Other Machine Company website has a great support page with a lot of different feeds and speed settings, and of course how to install the library, the tool library. Here's the actual link to download the tool library, and there's also a guide on how to set that up, I believe, which I will link below because it's not in this page, unfortunately. Maybe it is somewhere. Yeah, there it is. It just gives you the direct download link, but how do you install it? There is a guide on how to do that. But hey, that's it for me, guys. Thank you so much for watching, and I will see you in the next one.